In the last video we have seen the parity codes. What are the types of parity codes? In this video we are going to study the design of parity generator. First of all, we should be able to know what is parity generator, what is the need of parity generator. Parity generator is used for error detection in digital communication. We know that there are various methods used for error detection in digital communication, like parity codes is one of the method, then checksum method, CRC method, that is cyclic redundancy check. But parity method we have covered in the last lecture. In this lecture we are going to cover the design of parity generator, how to design a parity generator. We know that while designing any digital circuit, the first step is to draw the truth table. Okay. So here we are going to design a 4-bit parity generator. How? Suppose a 4-bit information need to be transmitted from the transmitter to the receiver, then how to generate, how to design a circuit, how to design a parity generator circuit for this input information. Here we are considering a 4-bit information. A, B, C, D is a 4-bit information. We know that when the information is a 4-bit, the possible combination for this information is 2 raised to 4, means 16 possible combinations starting from 0, 0, 0, 0 ending with 1, 1, 1, 1, that is 15 possible combinations are there. As we have already discussed about the parity methods, that when the input information is a 4-bit information, suppose in this information we have to add one extra bit, and this extra bit depends on the number of ones in the input information. If we are considering an even parity, then based on the number of ones, here the number of ones are 2, means the input information is already even, so we have to add an extra bit as 0. If you are considering an odd parity for the same information, here the number of ones are even, so the odd parity will be 1. Likewise, the even parity or odd parity is added with the original information. So for this 4-bit, the possible combination starts from 0, 0 to 1, 1, 0, 0, 0, 0 to 1, 1, 1, 1. Now for this, the P of even and P of odd bit is preset. For this information, we will see the number of ones. How many number of ones are there? Only 1, means 1 is an odd number. So even parity bit should be 1, odd parity bit should be 0. In this information, one number of ones are only 1. So even parity bit will be 1, odd parity bit will be 0. Here the number of ones are even, 2 number of ones are there, so the even parity bit will be 0, odd parity bit will be 1. Like this we complete the truth table for P of even and P of odd. Now next step is the minimization technique, how to minimize this expression. So for the minimization we use the different techniques. We use the Boolean algebra, we use the Karnaugh map technique with the help of Quine-McCluskey technique. Here we are going to minimize this expression with Boolean algebra. First of all, we need to write the output expression for the P of even, then for P of odd, then we will minimize the expression. Okay, one more thing we have left with, for the 0, 0, 0, 0, this information is neither even or nor odd. So what to do for this? For this information you can write any one of the 0, so the another one should be 1. I am considering P of even is 0, so P of odd is 1. So remaining in this way we will complete the truth table. Then next we write the output expression. Now for writing the output expression, as we have already discussed, what is the procedure? The procedure is you need to consider the number of ones in the output information. In the output expression of P of even, we will see the number of ones. See how many number of ones are there? These number of ones are there. For these number of ones, we will consider the input. For this input, what is the for this output, what is the input? We know that 0 is represented by bar and 1 is represented without bar. So for this one, A bar, B bar, C bar, D. So A bar, B bar, C bar, D. For this one, A bar, B bar, C, D bar. A bar, B bar, C, D bar. For this one, A bar, B, C bar, D bar. A bar, B, C bar, D bar. For this one, A bar, B, C, D. A bar, B, C, D. For this one, it is A, B bar, C bar, D bar. So A, B bar, C bar, D bar. For this one, A, B bar, C, D. So A, B bar, C, D. For this one, A, B, C bar, D. So A, B, C bar, D. And at last this one, A, B, C, D bar. So A, B, C, D bar. In this way, we will complete the output expression for P of even. Now next method, now next we will reduce the expression. How to reduce the expression? See, from these two terms, okay, a bar, b bar, c bar, d, and a bar, b bar, c, d bar. If we are taking a bar, b bar common, a bar, b bar common, so in bracket we are getting c bar, d plus c, d bar. C bar, d plus c, d bar, c bar, d plus c, d bar is the output expression of c XOR with d. Okay, so we are writing c XOR with d. Now from these two terms, if we are taking a bar, b common, so we are getting c bar, d bar plus cd. C bar, d bar plus cd is nothing but c XOR with d. Is nothing but c XOR with d. So we have replaced with c XOR with d. From these two terms, if we are taking a b bar common, so we are getting c bar, d bar plus cd, that is c XOR with d. And at last from these two terms, if you are taking a b common, so in bracket you will get c bar, d plus c, d bar, that is nothing but c XOR with d. In this way we will reduce this expression. Now again we will reduce, will take common c XOR with d, c XOR with d, we are taking common, so in bracket we are getting a bar, b bar plus ab, that is the expression for XNOR. So a XNOR with b, in bracket we are getting a XNOR with b. From these two terms we are taking c XNOR d common, so in bracket you are getting a bar, b plus a b bar, that is the output expression for XOR. So a XOR with b will be taken in bracket. In this way we will write this expression. Now we know that output of XOR and XNOR are complementary of each other. So we can write XNOR is nothing but complementary of XOR. So we can rewrite this expression as a XOR b complement. Okay, and in the same thing c XNOR with d can be written as c XOR with d complement. Okay, so all the expression comes in the form of XOR. Now we will observe, you can observe that this expression is in the form of a b bar plus a bar b. Okay, this complete term a b bar b. So we can replace as a XOR with b. So replace the values of a and b, you are getting a XOR b XOR c XOR d. In this way we can reduce the expression. This is the minimized form of this expression. Now next we have to write the output expression for p of odd. But for writing the p of odd expression, if we have observed the complete p of even, it is complementary of p of odd. Complete expression of p of even is complementary of p of odd. So we can directly write the output expression of p of odd is equals to a XNOR b XNOR c XNOR d. Directly we can write the expression, as we know that the complete truth table is complementary of each other. So complement of p of even is p of odd. So XOR का complement क्या होता है? XNOR. That's why we have directly written the output expression for p of odd. So the three steps we have done. First is the truth table. Second, in the designing, write down the output expression. Third, minimize the output expression. This is the minimized form of output expression. Why to minimize the output expression? Because minimum number of gates should be required for implementation of the circuit. Now the final step is the realization of these variables a XOR b XOR c XOR d. If we have 4 input XOR gate available, directly we can give the input to the 4 input XOR. For the practical purpose, you will have 2 input XOR gate available, so you can give 2 input also. Suppose a and b are the input of XOR, so you are getting a XOR b here. C and d are the input of an XOR gate, so you are getting c XOR with d here, and here one more XOR gate is applied, so you are getting p of even. Okay, in this way you are getting the output of p of even. For getting p of odd, you can connect one NOT gate over here, so you are getting p of odd. Okay, In this way you can design the parity generator. Thank you for watching the video.